we're going to talk about a fundamental rule that governs every single thing in the universe, from you just standing still to a rocket blasting off into space. It's Newton's third law, and it's all about a simple, kind of surprising idea. The world pushes back.
So to get started, let's ask a question that sounds super simple, but it's actually not. How do we move? I mean, really, how do you walk across a room? How does a car even work? The answer is probably not what you think.
You see, the short answer is this: the world pushes back. And no, that's not some kind of metaphor, it is the literal, physical truth. For you to move forward, you don't just push yourself, you actually rely on the world around you to push you.
Now, this pretty wild concept has a formal name that I'm sure you've heard before, Newton's third law of motion. But I think a much better name for it is the law of interaction, because that's what's really going on here.
And here it is, the famous line itself. For every action, there is an equal and opposite reaction. We've all heard it, we've all said it, but what does it actually mean? It turns out it's one of the most profound and, honestly, most misunderstood ideas in all of physics.
Okay, this is probably the biggest mistake people make. The words action and reaction make it sound like one thing happens and then the other thing happens in response. But nope, that's not it at all. These two things aren't a sequence, they are a simultaneous pair. They happen at the exact same instant, like two sides of the same coin.
So, here's the crucial part. Every single force in the universe comes in a pair, and these pairs always follow three simple rules. 1. They are always equal in strength. 2. They always point in opposite directions. And 3, this is the one people always forget, they are always acting on two different objects.
All right, that's the theory. Kind of abstract, right? So let's bring it down to earth and see how this law shows up in the real world, with stuff we see every single day.
Just picture a book sitting on a table. Easy enough. So, because of gravity, that book is constantly pushing down on the table. We can call that force the action. But of course, that's only half the story.
Because at that exact same moment, the table is pushing up on the book with an identical amount of force. That's the reaction. And that, right there, is why the book doesn't just fall straight through the wood. The table is actively holding it up.
Okay, now let's get things moving. When you take a step, what's your foot really doing? Well, you're gripping the ground with your shoe, and you are pushing the entire planet backward. Just a tiny, tiny bit, but you are. And we call that your action force.
And in return for that little push you give the planet itself pushes your body forward. That reaction force from the ground is what actually moves you. You literally cannot walk without the ground pushing you along. It's a partnership. And this simple rule, this push and be pushed back, isn't just for walking. It is the secret principle behind some of the most incredible feats of engineering and, yeah, even our own biology. Which leads us to a classic puzzle. If a rocket is out in the vacuum of space, there's no air to push against, right? No ground, nothing. So how on earth does it go anywhere? What is it pushing?
Well, the genius of a rocket is that it brings its own stuff to push against. It's fuel. The action is the rocket engine violently shooting hot gas out behind it. The reaction is that very same stream of gas pushing the rocket forward. That's it. It's really that elegant.
And hey, it's not just for high-tech rockets. When you go for a swim, you're doing the exact same thing. You cup your hands, you push the water backward. That's your action. And in return, the water pushes your body forward. That's the reaction.
Now this one messes with people's heads. In a car crash between a huge truck and a little tiny car, which one gets hit with more force? It's a trick question. Newton's third law is absolute. The forces are exactly the same. The force of the truck on the car is identical to the force of the car on the truck. Now the effects, the damage, the way they fly off are totally different, but that's just because of their mass. The forces in that moment of impact always perfectly equal.
So when you start to see these force pairs everywhere, you realize Newton's third law isn't just some dusty old physics equation. It's really a description of a deeply, deeply interconnected universe.
And this quote just says it all, doesn't it? There are no solo forces. Every single push, every single pull, from the bond between atoms to the gravity of a galaxy, is just one half of a two-way conversation.
So, what are the big things to take away here? First, every force is part of an equal and opposite pair, no exceptions. Second, you literally cannot touch anything without it touching you back with the exact same force. And finally, this simple hidden rule scales up to run the entire cosmos. And if you want one last mind-bending thought to leave with, just think about gravity. Right now, the Earth is pulling you down. We feel it. But what this law tells us is that you, yes, you, are pulling up on the entire planet Earth with the exact same amount of force. The only reason the Earth doesn't seem to move is because its mass is just, well, completely unimaginable.
So the next time you take a step, or lean against a wall, or even just sit in your chair, remember that you are in a constant, silent dance with the world around you. And it makes you wonder, doesn't it? What other unseen interactions are shaping your world at this very moment?